Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And a very good morning to our beloved lecturer, Prof. Madia Dr. Megat Ahmad Kamal Megat Hanafiah, and to our fellow friends. Today, my friends and I would like to present about Experiment 5, which is gas chromatography, and Experiment 6, which is high performance liquid chromatography. So, I will start first with the objective of the experiment. The objective for Experiment 5 are firstly to study about the principle of gas chromatography, and secondly to know the effect of temperature on elution order in gas chromatography. So objective for Experiment 6 are firstly to learn how to use high performance liquid chromatography, secondly to determine the retention time of each sample, thirdly to determine the amount of the caffeine contained in each sample, and lastly to determine the caffeine peak in each sample. Okay, now we move to the introduction. Chromatography analysis is a technique that can be used to separate complex mixture of the compound. There are two phases in chromatography, which is mobile phase and stationary phase. The mobile phase is gas or liquid that carry the sample through a solid stationary phase. There are many types of chromatography that exist in science world, but for this experiment we only focus to two chromatography, which is gas chromatography and high performance liquid chromatography. Next, we move to gas chromatography. Gas chromatography is a technique that can be used to separate their components based on the difference of the boiling point. Gas is being called as a gas carrier, and the example of the gas carrier is helium and nitrogen. Pressure that comes from a compressed cylinder contains the carrier gas that enough to create the flow through the column. Next, we move to the principle of the gas chromatography. Firstly, the sample is being injected at the injector and it will vaporize to the chromatographic column. The sample then will be transferred by the flow inert gases mobile phase through the column. After the sample passing through the column, it will separate and it will detect by the detector electronically. In this experiment, it consists two opposing forces, which is the first opposing forces is the vaporization of the compound, and the second is strong intermolecular interaction between the compound and the stationary phase. The compound vapor pressure will increase when there is a high temperature. Meanwhile, the strong intermolecular interaction with the phase will decrease the compound vapor pressure. Since the compound can only elute through the column when it is in the mobile phase, vapor pressure is used to determine the retention time. By using gas chromatography oven, it will be easier to control the vapor pressure. A gas chromatography analyst can be used to control the retention time of the compound and even alter the elution order by developing an oven software that suits to the analyzer.
Procedure of gas chromatography. In this experiment, we use Agilent 6890GC that being equipped with Agilent 5973 MSD. The samples that we prepare are benzene and butanol. 4 injections of benzene and butanol are being made by using different oven program. First oven program was isothermal at 30 degrees Celsius. For second, third, and fourth, the oven program changed to 10 degrees Celsius per minute until it can reach to 30 degrees Celsius. The peak analysis for benzene and butanol were being observed to determine the elution order change in both.
Now we move to the result for experiment 5. These 4 chromatograms show the reversal in elution order of two compounds, which is benzene and butanol. The result was achieved by only changing the oven program. The result in figure 2 show the boiling point of the benzene and the boiling point of the butanol. The boiling point for benzene is 80 degrees Celsius and the boiling point for butanol is 117 degrees Celsius. Hence, the boiling point of the benzene is lower than the boiling point of the butanol. So the result in figure 3 show that benzene have a strong interaction with Zebron ZB 5M Si stationary phase. Meanwhile, this interaction is not exist for butanol.
Next, I will share the discussion about two experiments that have been done. First experiment is about gas chromatography. Chromatography is used to separate mixture of chemical into individual components. Once it is isolated, the component can be evaluated individually. The experiment was conducted in order to find out the effect of temperature on compound elution order in gas chromatography. Thus, oven was prepared for benzene and butanol to undergo the elution order reversal. The oven program was isothermal at 30 degrees Celsius, and the temperature continued to increase until a ramp of 30 degrees Celsius was reached. Under the isothermal condition, benzene was eluted before butanol. But as the temperature continued to increase, the two compounds began to co-elute and separation process happened there. If the boiling point was compared, benzene has the lower boiling point by 37 degrees Celsius. Benzene also has stronger interaction with the stationary phase due to pi bonding with the phenyl groups in the phase. Benzene also had greater presence in the mobile phase as the oven temperature is closer to benzene boiling point than butanol's boiling point, while butanol's vapor pressure continued to increase over the oven ramp that caused by its less interaction with the phase. Hence, butanol eluted earlier relative to benzene with each increased the temperature ramp.
High performance liquid chromatography. HPLC use liquid mobile phase to separate the component from the mixture. The analyte will be dissolved in the solvent and then it will be forced through the column under high pressure. HPLC is a very efficient instrument due to the advantages and its ability, easy to handle, and it could separate the component from the mixture easily. Molecules can be adsorbed because the column in the HPLC instrument consists of very tiny particles that ensure the large surface area. The sample can be identified by comparison of their retention time. Next, we move to the HPLC principle. Firstly, the solute is being injected onto the top of the column. Then, separation process will occur when mobile phase and analyte are pumped through the column. Each of the components elute from the column as peak on the recorder. As a result, chromatogram is displayed. Chromatogram is the response of detector to each component. In this experiment, HPLC is used to determine the amount of the caffeine for several samples of beverage. Qualitative analysis in this experiment was determined by three methods. Firstly, by Dragendorf reagent. Secondly, by using Perry method. Thirdly, by comparing the retention time of each sample and caffeine standard. Quantitative analysis is done by HPLC for mobile phase and ODS for stationary phase. The flow rate in this experiment is 1 ml per minute and the detector used in this experiment is UV272 nanometer.
Procedure for caffeine in HPLC. In qualitative analysis, the samples were collected from different stores and labeled as sample X, Y, and Z. In Dragendorf test, 10 ml chloroform and 4 drops of NH4OH are being dissolved in 10 ml of each sample and must be filtered. To ensure that the solutions are high quality enough to run in the experiment, filtering must be done. The chloroform extract was being shaken with 6 ml H2SO4. Acid layer was separated into another test tube and being transferred into drop plate. Dragendorf reagents are being added and the results are recorded. In Perry method, the samples were dissolved in alcohol. Perry reagents and dilute ammonia were added. Results recorded to determine the existence of caffeine. Perry reagents are consisted of reaction between cobalt nitrate and methanol. In quantitative analysis, standard solution of 60 microgram per ml is being injected in HPLC system for 6 times to ensure that the injection port is full. The condition of HPLC system are as follows. Column reverse phase ODS 250 times 4.6 mm, detector at 278 nanometer wavelength, flow rate 1 ml per minute at room temperature, and mobile phase methanol to double distilled water are 95:5 in ratio. The caffeine standard soluble in ethanol with concentrations of 40, 60, 80, 100, 120, 140, 160, 180 and 200 microgram per ml were being injected into HPLC system. To identify the caffeine content in beverage, 5 ml of coffee sample were being inserted into separating funnel and being extracted for 4 times in each addition for 25 ml of chloroform. The bottom layer is taken and chloroform layer evaporated over water bath until the evaporation finish. The solvent-free caffeine extract then will be dissolved in 5 ml ethanol.
Next, we move to result for experiment 6. So table 1 shows the result of Dragendorf test on coffee beverage. It consists of 4 samples, which is the first sample is caffeine standard, second sample is sample X, third sample is sample Y, and the fourth sample is sample Z. All of the sample is clear sample before the reagent is added. After the reagent is added, the brown precipitate is appear in all sample. Positive means that all the sample contain alkaloid. Table 2 shows the result of perimeter test of coffee beverage. Before the reagent is added, all the sample is clear. And after the reagent is added, all the sample turns the color from clear to green. When the sample change the color from clear to green, that is mean there is caffeine present in the sample. Next, we move to the result for figure 1, which is the retention time for all sample. We still use the same sample, which is caffeine standard, sample X, sample Y, and sample Z. So, for B is a caffeine standard, for C is sample X, D for sample Y, and E for sample Z. As we can see in figure 1, B is a caffeine standard, which is the retention time for caffeine standard is 2.518. The retention time for C, which is a sample X, is 2.503. Okay, D is a sample Y, so the retention time for D is 2.493. And lastly, E is a sample Z. The retention time for E is 2.493, same as sample Y. As we can see, the retention time of the caffeine standard and other 3 samples is relatively the same. Hence, we can conclude that all the samples contain caffeine. Next, we move to the result in table 3, which is caffeine level in samples X, Y, and Z. So, for the first trial, caffeine level in sample X is 133.159, for sample Y is 106.953, and for sample Z is 148.797. For trial 2, the caffeine levels for sample X is 130.683, for sample Y 109.057, for sample Z is 146.292. So for the third trial, the caffeine level for sample X is 132.969. So for the sample Y is 109.583, and for sample Z is 145.541. So for the trial number 4, the caffeine level for sample X is 132.969, for sample Y is 112.038, and for the sample Z is 148.547. For trial number 5, the caffeine level for sample X is 131.445, sample Y is 110.810, and sample Z 150.049. And for the last trial, caffeine level for sample X is 131.064, sample Y is 109.758, and lastly, sample Z is 146.793.
Second experiment is about to determine caffeine in coffee beverage by using HPLC. There are 2 types of analysis have been done, which are qualitative analysis and quantitative analysis. Qualitative analysis consists of Dragendorf tests that change the sample to brown precipitate, while Perry tests show a form of green complex that happen due to cobalt ion as presence of caffeine compound. Furthermore, the retention time of caffeine standard was compared with HPLC contained qualitative analysis of caffeine. The average standard caffeine was 2.580 minutes, and the 3 sample is similar. Next, quantitative analysis was performed by injecting a standard solution of caffeine, 60 microgram per ml, at 6 times in a predetermined system. Ethanol that range 40 to 200 microgram per ml were used for linearity tests. Then, the caffeine content was calculated with the linear regression equation given. According to Indonesian Standard Agency, caffeine level that are allowed are 150 mg per day and 50 mg per serving. Besides, Food Drug Administration state that the dose of caffeine that allowed for adult is below 40 mg per day. The result of experiment show that caffeine does not comply where it should be 50 mg per day of caffeine in a sample, but as the sample XYZ that are obtained are exceeds the limit that was set by Indonesian Standard Agency for one serving of coffee. However, based on caffeine levels and FDA, it is past the standard.
In a nutshell, the two factors of compounds' boiling point and ability to interact with stationary phase were being considered in GC analysis. They are functioning in analyzing the vapor pressure and the elution order of chromatographic run. The elution order can be determined and arranged after the changes occur in oven program. The samples X, Y, and Z from coffee samples were proved to contain the relatively same retention time as standard caffeine. The caffeine content in sample X, Y, and Z obtained from coffee beverage per bottle were 138.048 mg, 109.699 mg, and 147.669 mg from the calculation of mean for each sample. This caffeine level, however, does not comply with Indonesian Standard Agency regulation. This is the list of reference that we use in our experiments case study. And that's all from us. Thank you.